So a representative from UNLC, or the computing School of Computing Student Advisory Board came by in the main section. They were not able to come here, so I'll just give them a plug as well. They are looking for new officers and people to take leadership roles in CSAB. Basically, it's a group that advocates for students. They are a liaison between faculty and students. So, for example, they have student advisory panels every year. That's their main thing, where they gather feedback on the program, on the facilities, on the courses, and then they take that stuff to the faculty, to the curriculum committee, and there have been effective changes. For example, even as of a year ago, you had to have 4 years of high school Spanish or any foreign language at all, world language, and in order to get out of the language requirements as computer science majors. And now, after years of advocacy, they finally reduced that down to 2. So if you didn't take all 4 years in high school and you only took 2, you can thank the student advisory panel or the student advisory board over the years for making that change. The second plug that I'll put in is Corn Hacks. So I've done Corn Hack. We've talked about Corn Hacks before. UNL Corn Hacks. All right. So there is no Corn Hacks as of right now because the officers that were in charge graduated, or the ones that were going to take it over are not able to do it. I've been advertising this as an opportunity for leadership to take it over. And I'm trying to find, a president, vice president, and then 2 sub-officers, treasurer, and outreach. And it is a lot of work, but in recognition of that for senior officers, it's not really relevant here, but like software engineers are required to take a 1-hour internship. In other words, they're required to find an internship. And so I'm offering that would fulfill the internship credit. So any of your software engineering friends, tell them that if they can't find a job, here's their job, right? It's not paid or anything like that, but I guess you're paid in good vibes, right? But I am looking for officers to take it over, and if you're interested, please speak to me as soon as possible. Otherwise, we'll have to go dormant for a year as we find some folks to do it. All right. So we were talking about objects because we were getting into object-oriented programming, right? And object-oriented programming is a little bit different from C. It's definitely different from Python because it's, at least the way that Java does it, it's completely different. Remember that objects have identity, state, and behavior. The identity is just some aspect that distinguishes it from all other objects. The state is its collection of properties. For a book, that would be the ID, the ISBN, the publisher, and the rest of this stuff. Its behavior is the functionality that acts on that. So, for example, for now, constructors, toString methods, and getters, right? We're gonna add more, non-trivial kind of behavior later on. But before we do that, let's make some observations about how Java does this, or at least how we've observed Java achieving these 3 things so far. What about identity? Well, how do you tell that something is different than another thing in Java? That equals and that hash code method that we talked about with respect to books, right? The equals method distinguishes that object from this object if they have different titles, if they are different things in memory, right? Whatever you want to put in there. I guess we didn't do that, did we? We did it for something, I thought. All right, well, let's do it now. Let me go ahead and go up to source and generate a hash code and equals. I thought we did this, but apparently I didn't. All right, there we go. All right, so equals. Right? It's actually quite complicated. Well, that object is equal to this object if they're the same thing in memory, and we return true. Otherwise, if they are not, if that object is equal to null, I can't be null because I wouldn't be here to begin with inside this function. So we can't be equal. False. If we don't have the same classes, then we can't be equal because you're a book and I'm a person, or you're a book and I'm an account, right? So we return false. Otherwise, we go through, and if they have the same author, the same book ID, the same date read, et cetera, if all those things are equal, then we ultimately return true. If any one of those things is not equal, then it ultimately returns false. Okay. So the equals in the hash code method are how Java achieves number one, identity, right? If you don't have that, then defaults take over and it's just the equals equals method or equals equals operation. Communication between objects is done via message sending. That's just a fancy way of saying that I'm going to call that object's functions, the getter, the setter, or any other functions that we might put in there. Right? We'll see better examples here later on. Basically, calling a function is telling the object what to do, not how to do it. Right? I'm sending a signal to that object to say, do something. Right? You know how to do it because you're a book and you know about book things. Right? I don't know how to do that because I'm not a book. I'm the main, or I'm a person, or something like that. Right? So calling a function is telling the object what to do, not how to do it. That's for the object to decide. Right? That communication is facilitated through what's called the interface. And for us, that's just simply the public methods that are available. Right? You can have private methods, by the way, right? But they are not considered part of the interface because nobody can see them outside the class. The class can see them. It's private to the class. And so maybe you want to have private methods, but it's not part of the interface. Right? Private methods may still be useful, right? So don't think that you can't make private methods. You can. It's just that be judicious about them, right? As we've also seen, and as you'll see today in your lab, objects are constructed rather than assigned. If I have an integer, int x is equal to 42, I am assigning that integer. The 42, first of all, a computer doesn't know anything about base 10, does it? Right? 4, 2, right? Those are just pixels on a screen. The compiler actually takes 42, converts it into a binary form, and then places that into a memory location. Right? All that detail is abstracted away by the programming language and the computer itself. Right? I can't do that with an object. Right? Instead, I have to call a constructor. Right? And Java has in Java, the constructor methods are named after the class. They have no return value, and they can take any number of parameters. For example, the book constructor here. Right? It has the same name. They're public, but you can have private constructors, by the way, if you really want to. But and there are use cases for that. It's not that silly, right? But for now, we'll just keep everything public, right? I've got one constructor that takes all of those pieces of data and sets all of those pieces of data. I've got another constructor here that takes an author and just sets the author, and that's it, right? It would actually be better if I had called the constructor this with 0, null, then the author, and then the rest of them null. Null, what is it, 0.0, what else is there? Rating, and then null, 0, and null, right? There. I got it wrong. What? Flexible constructor bodies? No, I got it wrong. So title, author, ISBN, rating, publisher, year, date read. All right, so let's get rid of that. There we go, that's why. Forget about the super, that was auto-generated anyway. All right, so this is, basically I'm calling that other constructor there. I'll prove it to you. If I click on it, it takes me to the other constructor there. That's a little bit better. That's slightly better if you're going to just set more than one thing, because now you are doing only one main constructor here that takes care of everything, and then you're passing in these default null values and zeros, right? So that's a little bit of an improvement, okay? But otherwise, we use constructors, right? And as you'll find out today in your lab, if you do not define a constructor, like a lawyer, a no argument default constructor will be provided for you by Java for free of charge, right? If you do define a constructor, though, that default one goes away. You can always restore it, and that's what you're going to do in your lab today. Okay? All right, so common patterns and common behavior when you're designing your objects. Make it so that specific constructors, like I just did, call more general constructors. Right? That's the DRY principle. What did that stand for again? Don't repeat yourself. All right. Now, I was only repeating one line. This .author is equal to author. But if I did more, or if I did more complex constructors, I would be repeating myself over and over again. There's another one. Did we ever cover this in CS1? Yagni? You ain't gonna need it. Right? In other words, don't over-engineer your objects. Right? For example, I have a person class, right? Person class is good, right? What about a name class? Right? So let's come over here to my person class, right? Well, last name, first name, that sounds like one thing. What if we put that into another class called name, and we have private name, right? That's going a little bit too far. Yagni, you ain't gonna need that, right? Let's back it up, and a first name and a last name is a person thing already. There's no need to complicate it by adding yet another class like that. How do you know the sweet spot? How do you know the Goldilocks zone of design, right? That's where your partner should come in, right? And you can have a back and forth. I think that we do need a name class. No, I don't think we need a name class. That sounds like a Yagni. You can have a debate about that, right? Of course, hopefully the Yagni individual would win. But also you have your design document, which is due this Friday, right? You're going to tell us your design. What are the objects that you're going to create? What are the classes that you're planning on creating? And we're going to say, okay, that looks good, but have you thought about this? Or you might be missing this, right? And we're going to give you feedback on that design. How do you know that it's a Yagni or not, right? And by the way, because this is an honors class, remember that you have your test case is also due this Friday, right? That means that you have to, I forget what it is, but you have to create like a persons.csv file, a products.csv file, and a customers.csv file or something, right? Use Mockaroo in the handout or use ChatGPT to generate dummy data, mock data if you want to. In that specific form, put it into your project as directed, and then build it and hand it in as directed in the handouts. And then the reason that we require that, it's bonus in the other class, and we'll grab theirs too, but it's required in here because it's the bonus, but also we're going to grab all of your test cases and we're going to put them in the grader, and you're going to be graded on each other's test cases. Don't worry, if a test case is bad, we're going to throw it out, right? So you're not being tested on bad test cases, okay? So that is due this Friday. Just keep that in mind, right? And here's the basic way of going about your object creation. You break real-world objects or ideas down into smaller and smaller parts until, 1, it is representable by a built-in type, a string, an int, a double, or engineering. What's the first question you ask yourself in engineering? Somebody already done it for you. An object already exists that does that, right? Either built into Java or you can bring in a library to do it, right? Okay. Generally, objects are composed of other objects or data. For example, in our book class, right, it was composed of a lot of things. It was composed of strings, which is a class, an integer, a double, and also a person, which is another class. That's what composition is. The book class owns an instance of the person class, is what we say. That's what this is known as composition, right? And you're going to be composing everything, right? Here's your first anti-pattern. Have you ever heard the word anti-pattern? You've heard the word pattern maybe, right? But maybe not in the context of coding. A pattern is a good guideline to follow. It's a good coding pattern to follow, right? And there's this book called The Gang of Four, or Design Patterns by the Gang of Four, and they've documented all of these different design patterns. You'll probably eventually cover it more formally in like software engineering or something like that. But there are also anti-patterns. Anti-patterns are bad behavior, are bad habits to get into. And one of them is called the God anti-pattern, right? A class should have a single purpose, a single representation. This is called the single responsibility principle, right? My person class should not be responsible for book stuff, and my book class should not be responsible for person stuff. They should have a single responsibility. Book is responsible for book stuff. Person is responsible for person stuff, right? If you violate that and start putting everything into one big class, what happens? That class knows everything. It sees everything. It does everything. It's a God now. It's a God class, right? Don't do the God anti-pattern, right? Make sure that you're adhering to the single responsibility principle. This is actually the S of a solid principles. We'll talk about the solid principles at the end. SOLID, right? It's 5 different principles that you should follow when you're doing object-oriented programming, right? All right, so those are objects. Object-oriented programming actually has other things. the four main pillars of object-oriented programming: abstraction, encapsulation, inheritance, and polymorphism. You're probably already familiar with abstraction and encapsulation from CS1, but we're going to look at it in a little bit more detail here, right? And then we're going to save inheritance and polymorphism for later because for next week because they're more complicated. Abstraction is simply just information hiding, okay? So the classic example I give in CS1 is the square root function. How does the square root function work? Anybody know? Is it a Taylor series? Is it an interpolation method? Is it a different interpolation method? Right? There are dozens of interpolation methods. Right? Technically, I don't know if Taylor series would be an interpolation method or not, but in any case, right? How does it work? Well, if you were really interested, what could you do? You could rip it open and find out. Right? That calls another function, that calls another function, and there's the actual code that does it. You've got about 100 lines of code, complex, really complex code here that does a bunch of bit twiddling techniques, all right, and a bunch of trickery here, right? So, you have your answer now, or what's the real answer, right? What's the real answer? When we talk about this in CS1, who cares, right? It just works, right? You know, you've got your phone. Most consumers just look at their phones or the square root button on their calculator, and they never even think about it, right? They don't care because they're trying to solve a different problem. That detail is abstracted away from them. They don't have to worry about those details. And in Computer Science 1, we call this procedural abstraction. The details of the function are hidden inside the function, and we don't have to worry about them. But what about object-oriented programming? Object-oriented programming, the representation is abstracted. Now, what do I mean by that? So I'll ask you another question. Consider, say, local date time. Or we were using local date last week, but local date time, let's just go with local date. All right, let's keep it simple. All right, how does it work? How does it represent a date? How does it represent a date? Say today, February 4th, 2026. What are some ways of representing dates? Say what? ISO 8601. By the way, if you're interested, there's an entire subreddit on ISO 8601 fans. And they're correct. They're absolutely correct on everything, right? It's a string, right? It's a string, like say today would be 2026 0204. Right? There we go. And then if you have a time on that, it would be a T and then the actual time. Why? Because it's lexicographically orderable. That is the only correct way of doing it, period. Right? Right? The Europeans get it wrong, Americans get it wrong. This is the correct way. Okay? What's another way? What if you had to do it yourself? Day, month, year, so 3 integers. Right? Day, month, year. Okay? What's another way that in computers time is represented? Unix epoch, right? A single integer, right? That is the number of seconds since January 1st, 1970. That's the Unix epoch, right? And if you want to, we can look here, Unix epoch converter or whatever. There we go. All right, it's doing it for me up there. What time is it right now? It's that time right there, right? And it's going to go up every second there, right? Why? Because it's counting the number of seconds since 1970, right? What happens before 1970? It just goes into the negatives. This is actually going to lead to a problem in a couple of years within your lifetimes. 2038 problem, Wikipedia. If you are using only a signed integer to do this, then in 2038 you're going to run out of numbers. And it's going to become 1908 again or something like that. Watch it over here. In 2023, oh, come on, I didn't want that. I closed it out entirely, sorry. 2038 problem, Wikipedia, that's what I wanted. All right, I won't click on anything right now. All right, watch as it goes from, looks like at about 3 o'clock in the morning, it's going to end up becoming, come on, just get to it. There we go. Now it's 1901, right? Same problem as the Y2K problem that probably happened before you were born, right? We only used 2 digits for a year. What happened in 1999? It became, instead of 2000, it became 1900 again, right? Now, this is only for computers that are only using integers, 32-bit signed integers. Most computers are 64 bits now, right? So you're good for several billion years, right? And if you're still using our computers today, several billion years in the future, you've got other problems than just this one, right? All right, so that's a Unix epoch. Again, I'm going to ask this question one more time. How does it work? Right? What's the real answer? Who cares? Right? It just does. Right? Now, if you really want to find out, then you just like we did for square root, you can go and you can rip open its guts. Save this. Let's get rid of that, and let's come over here to the book. It's the date read. There it is, local date. And if you scroll down, guess what they did? Year, month, day. But now, did you have to ever worry about that if you're working with this class? No. What'd they do? They created dozens and dozens and dozens of methods for you that do a lot of complicated things, like today plus 10 days, right? What date is it now? It takes care of all those details for you. It's all abstracted away, and you don't have to worry about it, right? That's what abstraction is about in object-oriented programming. You don't have to reason about the details. You only have to know how it works to use it, okay? You've also seen encapsulation, right? And more formally, encapsulation is basically also 3 things here, right? It's the grouping of data that act into one logical unit. That is, I've taken the book ID, the rating, the date read, and I've encapsulated it inside of one class here, the book class. Protection of the data from the outside world. I've made everything private so you can't muck with it, right? If you want to, you can go ahead and create setters, and now you can go ahead and make things changeable, although you should prefer immutable objects. I've grouped the methods or behavior that act on that data, the constructors, the toString method, the getters for now, and then we'll do more complex stuff later on. Hashcode and equals. It's all in the book class, right? It's not in the person class. It's not in the demo class, right? It's a book thing. It belongs in the book class, okay? All right, so generally, again, make all of your variables private unless there is a very good reason to do so, and that's all caps right there. There's very, very seldom a reason to do so. There's probably a better way, right? I've not seen yet a use case where, oh yeah, I can go ahead and make them public, other than just being lazy and I don't want to write getters and setters. You can be lazy still. Just go up to source and generate them for you, right? Right? You can make as many constructors as you want in order to make it flexible, right? Sorry, get back on track here, right? And like I said, you should avoid setters because you should prefer immutable objects, right? Everybody completed the PDC exam, and thank you for that. And it is part of and thank you for those who opted into using that for research. Basically, immutability gets you thread safety for free, because if you've got multiple threads or multiple computers in distributed computing environments that are trying to read the same data, and one of them can go and change the data, now you need to synchronize them so that I'm not looking over here at data that's been changed, right? That slows the entire process down, right? Whereas if it were just read-only, now who cares, right? You can read it all you want. I can't. Thread A, thread B, they can't change it, right? That gets you thread safety for free. Prefer immutable objects. All of the ones built into Java, strings, integers, doubles, they're all immutable, right? And they're immutable for a very good reason, right? There are 2 other patterns that we're going to talk about eventually. Actually, one of the patterns that we'll talk about eventually, a copy constructor here. We'll come back to that, though. I do want to put in a plug for doing the advanced activities in today's lab, though. Right? There's something called a builder pattern. Right? So, for example, let's come over here to the book to my demo class. How do I create a book? Book B is equal to new book. There's the ID, then the title, right? Then the author. Maybe it is. What was the order? What was the rating? Did rating come next, or did ISBN come next? I don't remember. Right? What you can do instead is redesign that class to have something called a builder pattern. So what you would do is you'd say book dot, actually new book. And I haven't made it, so it's not going to book, there we go, dot set title, right? And then you can set the title, right? Dot set ID, and then you can set the ID. Dot, right? Now, not only is this better because you can do it in any order. Before it was, it had to be with the constructor, it has to be the integer first, and then the title, and then whatever. I can do it in whatever order I want. And then also, the setter here tells me what I'm setting, so there's no mistake, right? That the title came before the ID or the ID came before the title. This is much more fluent. This is much more usable. And then at the end, you would say something like build, right? And then it builds it automatically for you and gives you your book back, right? Now, this is not going to compile because I've not written the code to do this. This is what you would explore if you do the advanced activity. It's not required, by the way, even though it's the honors section. The advanced activity is not required. It's just something that you should check out. Right? This is one of those design patterns I was talking about in the Gang of 4 book, right? It's called the builder pattern. I can show you one that works, though. String builder. Do you remember that? Right? SB is equal to new string builder. Dot, or let's go with this, dot append. Right? Hello. Dot append. Right, there we go. I'll just go like that. And then you can actually build it by going to string. They don't use the build keyword, not keyword, but they don't call it build, they call it to string. And then there's my string. Right? And generally what we would do is you would align all these things so that it's vertically aligned. There we go, and there we go. Right? So a string builder is a mutable version of it where you can make changes. You can append stuff, you can replace stuff. And then at the end, if you want a string out of that, you just build the string by calling this toString method. It's the same basic idea. You chain these things together. This is also called a fluent pattern. They work together. Builder pattern and fluent pattern. Okay. All right. So what I want to do with the rest of our time today is a demo, right? So consider a radioactive isotope, right? Now, you may or may not have taken chemistry, or maybe this is physics, I don't know. It's either or, right? That's okay. I'm going to describe what happens here. We all know what radioactivity is, right? So there are some elements that are radioactive. That is, that they decay into other elements and also give off radiation. Hopefully just alpha radiation, and then you can play with it all you want, right? You can, it can't penetrate your skin, basically. Alpha and beta decay, I believe, right? Just don't eat it, right? Because then once you let it can kill you that way. Otherwise, if it's, what else is there? Gamma decay and neutron decay, and those are super dangerous. You don't want to be anywhere close to those, right? Because those can kill you, right? Anyway, it eventually decays into stable isotopes or different isotopes. But for example, strontium-90, right? That is one of the byproducts of nuclear fission. So nuclear waste, or the waste in a nuclear explosion, right? That has a half-life of 28.9 years, right? And so there's still strontium out there in the Bikini Atoll and in Tokyo. It's still measurable after all, even though it's then 70 years, right? It's still measurable out there, right? If we start with 10 kilograms of strontium-90, then 28.9 years later, we will only have 5 kilograms of strontium-90. It doesn't just evaporate into nothing, by the way. It becomes uridium and zirconium, right? And those are also radioactive isotopes that eventually decay, and eventually everything goes into a stable isotope. Right? By the way, there was not a new radio lab. If you ever listened to that. Anybody? It's a science show, kind of. Yeah. They were talking about how researchers never really looked into how often the body replaces its cells, right? So, are there cells that live our entire lifetimes? Like our skin is replaced quite often because it suffers the most damage, and so because we had released radioactivity into the environment, they were able to study that stuff by taking samples and looking at the radioactive decay of isotopes to see how quickly the body replaces its cells. And they found that there are no, there are long-living cells, but there are no immortal cells, right? every cell gets eventually replaced at some point, right? And so I just thought that was interesting. Again, science, it's cool, right? You should think it's cool at least, right? All right, so here's our program though. We're going to take an atomic number, an element name, an element symbol, a half-life, and an initial mass, and we're going to produce the following table. Initially, you have 10 grams of strontium-90 here. 1 year later, you only have 9.6 or 9.76 grams, ... Once you get past 29 years, you have less than half of what you originally started because of the half-life. Each year, you compute that using the following. The original mass times 1/2, who would have thought, half-life, right? Raised to the power of the number of years divided by the half-life, right? So if years is 0, then what happens to this entire expression here? Becomes 1, and we're left with, in the first, before we start, we're left with the full mass, right? After 28.9 years, the exponent becomes 1, and so what do we have? 1/2, right? Half as much as originally we had, okay? All right, so for our first version of this, let's quickly just do a non-object-oriented programming version of it. In other words, let's just go ahead and approach this as if we were in CS1. I don't have any objects at all, right? The first thing I want to do is check for command line arguments. If args.length, how many am I reading again? If it's not equal to 5, right? If we want to, we can put this over here on the side, right? By the way, this is why computer scientists need 2, 3, 4 monitors everywhere, right? Yeah, because you need to put your IDE over here and your stuff over here, right? What am I actually reading? Atomic number, element name, element symbol, and then initial mass. And this is an image, so I can't copy paste, right? So if I don't get those things, what should I do? Print an error, to do, right? Come back and do a more sensible message there. And then I'm stuck. So I should exit, right? Okay? Otherwise, I'm going to read in those 5 things. The element name, string element name. I think number comes first, right? Int element number, right? Is that right? Atomic number, there we go. I'll just leave it as element number, right? Integer.parse int, all right? And that's going to be args of 0, right? Element name, that's going to be args of 1. Do I have to convert a string to a string? No, I'm just giving it a better name, right? Then it's element symbol, right? So that's args of 2, and I'll call this symbol, right? And then half-life, what should that be? 28.9 for strontium, so it should be a double, right? Half-life, right? Is equal to double.parse double of args of 3, right? And then finally the mass, right? So that's definitely a number, but what type of number should it be? Integer? Mass is equal to, what does the mass look like when you print it out? Fractional values, right? So let's go with the double there as well. Double mass is equal to double dot parse double parse double args 4. There we go. All right. Now, how would you go about producing this table? For now, I'm just going to ignore this header up here, right? You can come back and fill that in if you want, right? We'll have a better solution for it anyway later on, right? Elapsed years and amount. So I need my header. We'll put in that header, system.out.println years amount, or year and then amount. And there, that's good. Okay. So for the first year, I'm going to plug in year 1 into that expression up there and get a new mass. Then in the second year, I'm going to do that, and I'm going to get the second year's mass, et cetera, et cetera, et cetera. I'm going to do that until I have less than half of the original. For loop or while loop? While, all right? And let me just do it in plain English first. While the current mass is greater than or equal to 0.5 of the original mass, right? Then I'm going to compute the next year, right? And then the current mass is going to be equal to the current mass, or let's see, what would it be? The original mass times 1/2 raised to that power there. Original mass times 0.5 raised to the power of year divided by half-life. All right, there, life. There we go. Now, still lots of problems here, but I like to, and then I'm going to have to print it out. But I like to type it out even though I don't have these variables because I can always go back and say, oh, I need those variables now. So double current mass. Where should I start it? At the mass that you read in. Double original mass. What should I start that as? As the original mass, right? Do I really need 3 variables? No. But I'm going to keep it this way for now because we're going to refactor this to be more object-oriented programming. Right? All right. I do need year. And what should that be? Int, right? Year. What should I start it out as? 1? Okay. All right. Although if I increment it immediately, then, all right, yeah, I like that 0 better. All right. Okay. I could just change where this is done, but I like this a little bit better. All right. Can I do power like that in Java? Nope. Can I do it like that in Java? Nope, that's Python. You can do that in Python. So how do I do powers in Java? Math.pow. And I'll raise 0.5 to year divided by half-life. Wonderful. Right? Integer truncation issue here, potentially? Year is an integer, but is half-life? Nope, we're good. All right. And let's go ahead and print it out. System.out.printf %d for the year, and then tab over whatever you want to do. %.2f grams for the mass. So year and current mass. There. Okay? Is it going to work? Let's find out. Okay. Error to do. All right, so let's go ahead and go over here. And this is, the isotope's name is strontium 90. Right? And it's I think it's 38 is its atomic number. Then strontium 90. Then the element symbol is SR. And then the half-life is 28.9 years. And we have 10 grams that we're starting out with because that's what's in the handout. There we go. Did it work? Looks like it to me. All right. Now we just need to go back, refactor, and put in documentation and stuff like that. But what we're going to do is this is not object-oriented programming at all. Right? The first thing that I'm going to note here is that I've got multiple pieces of data that constitute one thing, an isotope. This is violating encapsulation. So let's fix that. What would you do? Yeah, an isotope class. New class isotope. There we go. And what is an isotope? Well, it's those 5 things. Let's go ahead and steal those 5 things and bring it over here. Right? Now, you don't set, you can set these, but there's no command line arguments here for me to do this with. So I'm going to go ahead and get rid of all that stuff. Get rid of that, get rid of that, get rid of that. Right? And get rid of that. Right? Oops, there. Okay. Step 1. Now I have grouped data into one logical unit. I now need to, and I'm going to skip to step 3 here. Let's group methods or behavior that act on that data. What are the standard things that you should do with your objects when you start creating them? Well, you're going to need a way to not assign them, but to construct them. So, constructor using fields. Done. Right? What else are you going to want? Getters, okay. Let's go ahead and go with all. Do we want setters? No, we want immutable objects, preferring immutable objects. We won't take off for it, but we will note it every single time and encourage you not to do it, right? All right. And then what else do you want? Maybe equals hashcode, but that's not relevant right now. A toString method, right? And I'll go ahead and generate it like that, but I'm going to go ahead and come in over here and immediately replace it with my own, right? I want it to look like that thing right there, right? And that's why I didn't do it initially, right? I can select text there. All right, I don't know why. All right, so string.format. Do you remember what that does? That's printf style formatting, but it puts it into a string. It prints it to a string like sprintf instead of to the standard output. So I want the name %s, and then in parentheses I want the symbol, and then the what else? I guess it's the atomic number, percent %d, and then that, right? So this dot element name, this dot element number, and this dot element symbol. There. Okay. So I've done 1 and 3. Right? I'm going to hold off on 2 here, and we're going to see the consequences of that. Let me go ahead and come over here, and now I can take those 5 pieces of data from the command line, and I can create an isotope sample. Right? Equals new isotope, and it's going to be element number, element name, element symbol, half-life, and mass. There. Okay. Now, I've not done number 2 yet of encapsulation, the protection of that data. The consequence of that is sample dot element name. You're no longer strontium, you're adamantium. There you go. Is that even a real one?
Yeah.
It is?
Well, not an element.
Yeah, it's not an element, right? Well, it's not even real, right? It's just Wolverine, man, right?
Oh, that is fictional one.
It is a fictional one, but that's not real, right?
Oh, I thought it was. I'm not
Right. Or maybe vibranium. There's no such thing as vibranium. All right, so I've violated encapsulation because I've let it to be public, right? Let me come over here and now do number 2 of encapsulation. Make sure that everything is private unless you have a very good reason to do otherwise. Private. Done. Okay? Now I'm not able to do something like that over here, right? Okay, good. So I've got encapsulation down. Now what about abstraction over here, right? So let's take a look at the rest of this code here. What is it actually doing on line 41? It's decaying, right? It is taking the original mass and then it's decaying it by a year, by 2 years, by 3 years, until you get down to the original half. That sounds like an isotope thing to me, right? It sounds like a behavior of an isotope decays, doesn't it? But I've located it in the demo class. Does that sound right? If it's an isotope thing, where does it belong? Isotope class, right? So let's come over here and let's give it our first non-trivial behavior, our first non-trivial interface. Public void decay. That's how I'm going to send a signal to the sample to decay yourself by some amount, right? I'm going to take this complex math, right? It's not very complex, right? And I'm going to move it to where it belongs, in the isotope class. Now we're going to have to fix this, right? This dot mass is equal to this dot mass times, and then how, like I've got a half-life, right? I know about my half-life, but I don't know how many years you want me to decay. At this point, I do need to bring in a parameter. Int year. Right, there we go. That'll work. Let's improve it though. Should it be an integer? You can only ever decay yourself by 1 year. No, stuff is being decayed all the time, right? Americium is being decayed right up there in that fire detector, or that smoke detector, right? That's how it's a small amount of radiation, but and it's alpha decay or beta decay, but that's how smoke detectors work. They have a small amount of americium in them. Americium, is that how you spell it? Pronounce it? All right, sure. All right, fine. All right, so do we only want to go with years here? Double. That allows me to do 1 year. It allows me to do 1.5 years. It allows me to do 0.000005 years, right? If it's on the seconds or something, right? All right. Let's come back over here and look how much it improves, right? So I'm going to say sample dot decay yourself by 1 year. Isn't that so much better? Right? I've offloaded, I've abstracted away the idea of decay inside the class. It's an isotope thing. It belongs in the isotope class. It's complicated, right? And it knows how to do it. All I have to do is communicate to it and say, decay yourself by 1 year. Right? How much better is that? Right? That's loads better. Hopefully, you see, right? Immediately, right? Now, obviously, I'm going to have to change a whole bunch of other stuff as well. It's not the current mass anymore. It is the samples mass. Get mass. Right? There we go. And sample dot get mass. There we go. Now, hopefully I didn't break anything. Exact same behavior here. But how much better is it with object-oriented programming? I don't have to reason about what this means here. Right? All right, come back in 3 months. Are you going to remember what that 1 stood for? No. What are you going to have to do? Going to have to come over here and read the documentation that we didn't write, right? Decays this code, this isotope by 1 year. Right, there we go. Okay. Results in some other mass, right? By the way, can I ever go negative? Can you have a negative out of a power there? I don't know. It's just the reciprocal, right? So you can never have a negative here, right? And that works, right? I would have to read that every single time. Or I would have to come over here and say, oh, year? Oh, okay, it's a year, right? 1 what? 1 year, 1 second, 1 day, right? All right, well, one way that you can solve this is by saying decay by year. That's getting into kind of a Polish notation or something like that. I forget what it is, where you put the type or the unit in every single variable name, right? You don't want to do that, right? Well, you could say, okay, decay this by some unit of time. That's what I would like, right? And then what you could do is you could pass in 1 second. You could pass in 5 years, right? You could pass in whatever you want. Right? So when you're designing your stuff, I want a notion of a time span, right? Not a moment in time. That would be a date time, right? But I want a notion of 5 seconds or 10 years or 1 year or something like that. So generally, when you are faced with this, right, what question do you ask? Is there already one that exists, right? And there is. In the same date time library, you're going to have a duration, D, right? And let me go ahead and bring that in. What is a duration in the date time library? It is a time-based amount of time, such as 34.5 seconds, right? Now, how do I translate that into year over here, right? And for that, I'm going to have to remind myself really quickly here. Oh, did I not have it? Duration. There it is. Okay. Oh, yeah. Okay. So the duration D dot 2 days, right? Divided by, because this unit, I want it in years. Actually, let me bring this out. Years. There we go. And this will be int years is equal to, I want to convert that to days. And how many days are there in a year? Careful. 0.25. Why? Those pesky leap years. Right? It's actually like 4 and then change. We do have leap seconds, by the way. But I'm not going to worry about that. I'll just keep it simple like this. Right? And this would, yeah, let's go ahead and change this into double now. Double year. There we go. There. All right. All right, we only have 2 minutes here, and we'll continue this on Friday, but is there another way that I can make this even more flexible? So remember back to CS1 when we said, oh, well, we've got a void function now because we've got passed by reference variables. And that frees up the return value to return something, right? What would be useful here in this case? Think about that, and we'll come back on Friday, and I'll leave that bug there to remind us of what to do. Right?